Today's October 26th, and we are doing a review of quadratics. Today is the first day of reviewing quadratics, and then we'll continue tomorrow. So I'm going to do the highlighted problems on this worksheet, and then the rest of them will be for you all to do. So on each of them, we have to find the minimum or the maximum, the vertex, the axis of symmetry, the x-intercept, which are the zeros, if there are zeros, and then the y-intercept and the domain and range. So it seems like a lot of information, but a lot of our parts are going to give us other parts. So on number 2, we have y equals x squared plus 2x plus 3. So on number 2, y equals x squared plus 2x plus 3. So remember, when we're in standard form, let me write it out for you. We have ax squared plus bx plus c. So my a value is 1, my b value is 2, and my c value is 3. So for the minimum or maximum, we need the vertex. The vertex we're going to find by finding the axis of symmetry first. So for the axis of symmetry, we'll do x equals negative b over 2a. So negative b would be negative 2 over 2 times 1, which is negative 2 over 2, which reduces to negative 1. So my axis of symmetry is x equals negative 1. So I'm going to go ahead and write that over here. Remember, my axis of symmetry is going to cut my quadratic right in half. It's going to cut the parabola straight through the middle. So it has to go through the vertex. So in order to find the y of the vertex, I'm going to plug in that x value. So y equals negative 1 squared plus 2 times negative 1 plus 3. So I'm plugging it into the original equation to find the y value. So y equals negative 1 squared is negative 1 times negative 1, which is a positive 1. 2 times negative 1 is a negative 2, and then plus 3. 1 minus 2 plus 3, we've got 1 plus 1, which is 2. So my y value is 2. So then when I'm writing my vertex, it is the point negative 1, 2. Now, since this has a positive a value, it's going to be facing up. You can make it happy, it's positive. So it is going to have a minimum value. And the minimum value depends on the y value of the vertex. So my minimum value is 2. That's also going to affect my range. So I have a parabola that is going all the way down to 2 and then going back up. So the range will go from 2 all the way up to positive infinity, and then it goes positive infinity down to 2 and then turns back around up to positive infinity. So my lowest value is 2. Then for the zeros and the y-intercept, we're going to have to plug in zeros for the values. And the domain, remember, will never change. So we have negative infinity to positive infinity there. So back over to this left side. To find my zeros and y-intercept, first I'm going to find my y-intercept. I'm going to plug in a 0. Remember, with my standard form, that's super easy because it's going to go y equals 0 squared plus 2 times 0 plus 3. So the first two will always cancel. So y equals 3. And then when I'm writing my y-intercept, I make sure that the x value is 0, and then the y value is whatever I got. So now the only thing left is to find my 0. Now, remember what I said last week, that when we're finding our 0, we got to make sure that we have one first. So I'm going to sketch a very poorly sketched graph. Oops. This is a rough sketch. So don't take this for accuracy, okay? So I have a parabola that is facing up, and it goes all the way down to 2 and then turns back around. So my vertex is at -1, 2. So here's my vertex. Remember, we're facing up. I don't know how wide it is. I don't know what points it's hitting exactly, but I know that it's facing up and my lowest value is 2. Because of that, I'm never crossing that x-axis. So there's no way I could have any zeros. So for zeros, I would say none. And then I am done with number 2. Now on number 4, I have -2x squared minus 16x minus 33. So I'm going to get rid of all this so I can have enough space. Delete that. So now I'm on number 3. Oh, sorry, number 4. We're only doing the right side of this page. So y equals -2x squared minus 16x minus 33. So remember, you don't have to find these things in order. We just need to make sure that we find all of them. So I'm going to find my axis of symmetry first. X equals -b. Well, let me label everything first. So -2x squared. Oh, that 2 looks a little funny. Okay, so my a value is the first one, so -2. My b value is the second, and c is last. And I know you're probably wondering, what's the point of writing c every time? Because we haven't used it yet, but we will be using it once we start solving with quadratics. So I'm trying to get you into the habit of writing out the c. So just make sure that every time you're writing it out, so that way once we move into solving, it's not an added-on step. It's just something that you're really used to doing. So we have our a, our b, and our c. So my axis of symmetry is x equals -b over 2a. So that's -16 over 2 times -2. So I'm going to work with all those negatives real quick just so I can get their signs where they're supposed to be. So negative of -16 is a positive 16. 2 times -2 is -4. So now 16 divided by -4 is -4. So I have x equals -4 as my axis of symmetry. Sorry about the interruption. Someone came in my room real quick. So we just found that the axis of symmetry was x equals -4. So now I need to plug in my axis of symmetry value, that x value, in order to get my vertex. So I'm going to write that axis of symmetry real quick. So x equals -4. And now I'm going to plug in that x value to find what my y value would be. So y equals -2 times -4 squared minus 16 times -4 minus 33. So just plugging in that -4 everywhere that I see an x in the original problem. And then I'm just going to work this out. So at this point, you could plug this into a calculator if you wanted to. I'm going to work it by hand. So I have negative 4 squared, which is 16. So y equals negative 2 times positive 16 minus 16 times negative 4 minus 33. 2 times 16 is 32, so we have negative 32. 16 times 4, I think is 64. Yeah, so we've got positive 64 since they're both negatives, and then minus 33. So negative 32 plus 64 minus 33. So we have negative 65 plus 64, which is negative 1. So I have my y value and my x value, which means my vertex occurs at negative 4, negative 1. Now looking at the equation over here, this is a negative value, so my parabola is facing down, it's negative, it's sad, so it's going to have a maximum value. Maximum value is negative 1. We just take the y value from the vertex. And so now we're going to write out our domain and range. Domain doesn't change, negative infinity to positive infinity. And then the range is going to go all the way up to negative 1 and then turn back around. So we're going from negative infinity up to negative 1, turn back around, go back down to negative infinity. So now we're going to find our y-intercept by plugging in a 0. So y equals negative 2 times 0 squared minus 16 times 0 minus 33. Remember, in standard form, it's super easy. Those go to 0, so we're left with y equals negative 33. So my y-intercept is 0, negative 33. Now to find my zeros, I need to see, do I have zeros first, and then how many will I have? So I'm going to draw a rough sketch. Remember, this is not an accurate sketch. I don't know how wide it is. So I have this sketch here with a vertex at negative 4, negative 1. So that's 1, 2, 3, 4, negative 1. So here's my vertex, and I am facing down. So will this ever cross the x-axis? No. So because it doesn't ever get close enough here, it's never going to have a 0. So again, we have no x-intercepts. So now we're going to do number 6. I'll clear this out. So on number 6, we're still in standard form. We have y equals negative 3x squared plus 12x minus 16. You can do this in any order you want. So if you want to first go, well, I know that the y-intercept is going to be where there's zeros for x. That knocks out the first two. My y-intercept is 0, negative 16. And you can do that. You know that's going to happen. So just go ahead and write in your y-intercept. Because this is written minimum, then vertex, axis of symmetry, doesn't mean you have to go in that order. So we already started with the y-intercept. Now I'm going to find my axis of symmetry. I write in my labels. A is negative 3. B is 12, C is negative 16, x equals negative b over 2a, so it's negative 12 over 2 times negative 3. So that's negative 12 over negative 6. Negative 12 divided by negative 6 is a positive 2. So x equals positive 2 is my axis of symmetry. X equals positive 2. So now we're going to find our vertex by plugging that value in. Y equals negative 3 times 2 squared plus 12 times 2 minus 16. So again, at this point you could plug it straight into a calculator and find what your y value is, but I'm going to work it by hand. So y equals negative 3 times 2 squared, which is 4, plus 12 times 2, which is 24, minus 16. Y equals negative 12 plus 24 minus 16. Y equals 12 minus 16. Y equals negative 4. So we have that our y value when x is 2 is negative 4. So that gives me a point at 2, negative 4. That's my vertex. Domain and range. Here we have a negative, which means our parabola is facing down. So we have a maximum value, negative 4. So for my range, my maximum value is negative 4. So we're going from negative infinity all the way up to negative 4 and then turning back around. Domain will not change. So negative infinity to positive infinity. We already found our y-intercept by knocking out those first two values. And then for our 0, let's do a rough sketch of our graph and see if we're crossing that x-axis at any point. So our vertex is at 2, negative 4, somewhere down here, and we're facing down. So I am never going to hit this line up here. So we did not have any zeros. So then the last one on this first page that we're going to do is number 8. Let's mark that out. So number 8, we have y equals negative x squared minus 2x plus 1. So I'm going to go ahead and write in my y-intercept. I know that it would mark out the first two values because they would become 0. So we would have 0 plus 1, which is just 1. So my y-intercept is 0, 1. So now I'm going to find my axis of symmetry. So A is a negative 1, B is negative 2, and C is positive 1. X equals negative B over 2A. So that's negative times negative 2 over 2 times negative 1. Negative of negative 2 makes a positive 2. 2 times negative 1 makes a negative 2. 2 divided by negative 2 is negative 1. So my axis of symmetry occurs at x equals negative 1. So then I'll go ahead and find the y value of the vertex by plugging that negative 1 in. So negative 1 squared minus 2 times negative 1 plus 1. You can plug that into the calculator. I'm going to work it by hand. So we have a negative on the outside, and the negative 1 squared is negative 1 times negative 1, which gives me a positive 1. So we have a negative 1 times 1 minus negative 2 times 1, negative 1, which is a positive 2, plus 2. So negative 1 plus 2 plus 1, which gives me 2. So my x value is negative 1, my y value is 2, so it gives me my vertex, negative 1, 2. My parabola is facing down because it has a negative first value. So it's a sad parabola, which means that it's going to have a maximum value and turn back around. The maximum is the y value of the vertex, which is 2. Domain and range, the domain is not going to change. Negative infinity to infinity. And then the range will go up to 2 and then turn around. So we have negative infinity all the way up to 2, turn back around. Now for the x-intercept, let's see how many, if any. So let's sketch out this graph. So we have a parabola that's facing down with a vertex at negative 1, 2. So there's my vertex, and it's facing down. So we have 1 over here and 1 over here. We have 2 zeros. So here we have the zeros would be found by 0 equals negative x squared minus 2x plus 1. Now, I cannot factor this because even if I divided by a negative 1, I would have to find two numbers that multiply to negative 1 but add to 2, and that's impossible. So what I'm going to do to find the zeros is use the quadratic formula. Now we're going to have a couple days that go over the quadratic formula. So if you have to use it now, don't freak out. If you don't know how to use it, that's okay, because we're going to go back over it. So the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. If you've heard me sing the song for the quadratic formula, then you are very lucky because it'll never happen again. So we're using the quadratic formula, and we've got x equals negative b, so positive 2 instead of negative 2, plus or minus the square root of b squared, 4 minus 4 times a times c. And that's all over 2 times a. So we have 2 plus or minus the square root of 4 minus 4 times negative 1 times 1 is 4 plus 4. Over negative 2. 4 plus 4 gives me a square root of 8. So we're going to move that negative to the top. Negative 2 plus or minus square root of 8 over 2. Square root of 8. Let's rationalize. I know y'all don't like rationalizing. So we've got 2 times 4, which is 2 times 2. So that gives me a pair here with a leftover 2. So this is 2 square root of 2. So we have negative 2 plus or minus 2 square root of 2 over 2. And then I see that they all have a 2, so I'm going to divide out that 2, which leaves me with negative 1 plus or minus square root of 2 over 1, which is just negative 1 plus or minus square root of 2. So for my zeros, my x-intercepts, we're going to have -1 plus square root of 2, 0, and -1 minus the square root of 2, 0. So if you struggle with your x-intercepts, do not worry about them for now, because we will be going back over the quadratic formula and how to solve quadratics. So if you are absolutely struggling, it is absolutely okay. Just leave those blank and make sure you're getting this through here and this through here. So now we're going to move on to the second half of this. Let me clear this out. So on the second page, I am going to be doing the right side. Oh, sorry, the left side. The left side instead of the right side. And then on the second page, we see that they are in vertex form. So in vertex form, that is well, let me start with y equals a x minus h squared plus k, where hk is the vertex. So that's going to give us the vertex, the minimum, the maximum, and the axis of symmetry, and the range. So we're going to get all of that just from the equation. So the vertex we find by looking at the equation. We're going to take the opposite of what's inside with x, so -3, and then that last number as it is. -3 is my maximum or my minimum. Since this is positive, we're facing up, which means it is a minimum. So my minimum value is -3. My axis of symmetry is the x value of the vertex, so x equals -3. My range is going to go down to -3, but all the way up to infinity since it's facing up. Domain will not change. And then we have to find our y-intercept and see if we have any x-intercepts. So my y-intercept is going to occur where x is 0. So 3 times 0 plus 3 squared minus 3. 3 times 9, so we're squaring 3 minus 3. 3 times 9 is 27 minus 3, which is 24. So the y value on that y-intercept is 24, and my x value would be 0, so 0, 24. And then I need to find my x-intercept, or see if I have any. So we'll do a rough sketch over here. I have a positive quadratic, so it is opening up with a vertex at -3, -3. So it's over here, and it is opening up. So it will cross the x-axis. So I need to find my x-intercepts. So 0 equals 3x plus 3 squared minus 3. Add 3 to both sides. We get 3 equals 3x plus 3 squared. I'll divide out that 3 in the front on both sides. That gives me 1 equals x plus 3 squared. In order to undo a square root, undo a square, I have to square root both sides. So we get plus 1 equals x plus 3, and negative 1 equals x plus 3. So remember that we saw last week with our square roots that they give us positive and negative values. Square root of 1 is 1, so we get positive 1 and negative 1. And we know that we need 2 zeros, so it makes sense that we would have to find 2 values. So we have minus 3, we get 1 minus 3, which is negative 2, as our x, and we get negative 4 as our x. So we have 2 zeros that occur, one at negative 2, one at negative 4. So we have negative 2, 0, and negative 4, 0. And then that problem is done. So now we'll do number 11. Clear this out. So at number 11, we're finding all of that information, but again, we're in vertex form, so it's going to go a lot quicker. We have our vertex by taking the opposite of what's inside, so positive 1, and then that last piece as it is. So 1, 1 is our vertex, which means our maximum or our minimum is at 1. It is negative, so we have a sad parabola. So that means we have a maximum value. So the maximum is at 1. Axis of symmetry is the x value of the vertex, so x equals 1. Domain and range. Domain will never change, so negative infinity to positive infinity. And then the range goes all the way up to 1 and then turns back around. So we would go negative infinity, all the negative values, all the way up to 1, turn back around to those toward negative infinity. Now we need to find our x and y intercept. So for the y intercept, we're going to plug in a 0. So negative 2, 0, minus 1 squared plus 1. So y equals negative 2 times negative 1 squared is a positive 1 plus 1, negative 2 plus 1, which is negative 1. So for my y-intercept, the y value is negative 1, and of course that x value is 0. And then let's do a rough sketch to see if I have any zeros and then how many if I do. We have a sad parabola here that goes all the way up to 1. So 1, 1 is my vertex, and it is a sad guy. So we do have zeros, and we have 2 of them. So in order to find my zeros, I'm going to plug in a 0 for y, negative 2, x minus 1 squared plus 1. We're going to be dealing with fractions here. So we're going to subtract 1, negative 1 equals negative 2, x minus 1 squared, divide by negative 2, 1/2 equals x minus 1 squared. And then in order to get rid of that square, I have to square root both sides. We get 1 over 4 x minus 1 squared. Oops, not squared anymore, x minus 1. And so I'm going to say positive 1/4 equals x minus 1, and negative 1/4 equals x minus 1. So I'll add 1, And 1/4 plus 1 gives me 5/4 or 1 1/4. And then for the right side, we have negative 1/4 plus 1, which is 3/4. So my two x values, remember, if this is going too fast, that's okay. You can leave those x-intercepts blank for now, but then when we start going into how to solve these quadratics, then you're going to want to go back and figure out how to find those zeros. So we have 5/4 and 3/4 for our x values. So we have an x-intercept at 5/4 and then 0, and then we have one at 3/4 and then 0. So now we'll move on to number 13. Let me clear this out. We have a lovely little equation in vertex form, so we're going to fly through all this information until we get to the intercepts. So we're going to take the opposite of what's inside, so positive 1, outside as it is, that's my minimum or my maximum. It's a negative, so it's a sad little parabola. So it is going to go up to -2 and then turn back around. Axis of symmetry is the x value, so x equals 1. And then domain and range. Domain does not change, -infinity to infinity. Range, since it is a maximum value, it's going to go up to -2 and then turn back around. So we have -infinity up to -2, and then that closes it off. So now we have our 0 and our y-intercept, left. So y-intercept, we're going to plug in a 0 for x, so -2, 0 minus 1 squared minus 2. -1 squared is -1 times -1, so it's a positive 1 minus 2, which gives me -2 minus 2, which is -4. So my y-intercept is occurring at 0, -4. And then let's sketch out this guy and see if we have x-intercepts or zeros. Alright. So we have, oh, my hand slipped. We have a negative parabola, so a sad little guy here. And his vertex is at 1, -2, so positive 1 and a -2. And he's sad, so we're facing down. Uh-oh, we're not going to cross this line. So since we're not going to cross that line, we have no zeros, so we would write none. I think that was the fastest one that we've done. And of course, if you need it to slow down, you can slow down the video. If you're in class, you can ask your teacher to go back over number 13. Or if you are virtual and you need some help, then you can come to tutorials, or you can just send an email and say, hey, I really need some help on number 13 because she went way too fast. So on 15, we're going to do the same thing. I'm going to try to slow this one down, okay? So in our vertex form, we're given the vertex here. This is minus h. And here, because this is plus k. And my vertex is hk. So h, I have to take the opposite of what's inside with x. So since this is minus h, then I have minus -1. So my vertex opposite is -1. And then my k, I take it as it is. So 2, it's positive 2. That is my vertex. So let me show you what I mean. I have a positive a value. This is a right here. and it's a positive a. So we got a happy parabola, and its vertex is at negative 1, 2. So negative 1 on the x, oops, positive 2. So here is our vertex, and we have a happy parabola that is facing up. So I already see that I'm going to have no zeros since I won't cross that axis. So I'm going to write in none. And then when I'm sketching my axis of symmetry, the line that will cut it straight in half has to go through that vertex, and that gives me my axis of symmetry, but it's a straight up and down line, which is an x equals line. So it is the x value of my vertex. Minimum, maximum. So since we're facing up, we have a minimum value, and the minimum value we have on the y-axis is 2. I get that straight from the vertex. Domain will not change. This video is just a mess. I'm so sorry, the program crashed. So our domain is negative infinity to positive infinity. And then our range depends on our y-axis. So we're going from up here, all the way up here, forever, 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 down to this value, and then turning back around. So we're going to hit every single y value above 2, but nothing below it. So when we're writing in our range, we would go nothing below 2, we're blocking off the lower end, but everything above it. So we have 2 to infinity. And then for my y-intercept, that's where we're going to plug in a 0 for x. So we have y equals 2 times 0 plus 1 squared plus 2. Y equals 2 times 1 squared, because 0 plus 1 is just 1, plus 2. Y equals 1 squared is 1, so 2 times 1 plus 2. Y equals 2 plus 2, which is 4. So my y value is 4, and that is my y-intercept. So 0 on the x, 4 on the y. And then we've written in all of our information for number 15. So your homework for today is to do the other 8 problems. So we did half of them together, and then you guys will do 1, 3, 5, 7, and then 10, 12, 14, 16.